Okay, so today I thought we would go back over looking at target 1.1, which says I can use function notation appropriately. Now, function notation is just another way that we write equations. Most of the time you've seen linear equations, things like that, written in the form y equals something x, like 2x plus 4, something along those lines. But we can also write it in what is called function notation. And what that says is that we have a function that involves a variable x, and the output of that function is given by this little expression right here. I'm going to underline this in green. This is the output of our function. In other words, it's what we get excuse me, when we plug in a certain value of x. So we would say we have a function 2x plus 4, and the output will equal our answer when we plug some value in for x. So x is what we call the input. It is the number that we plug into the equation, and the f of x is what we get out of the equation. So for instance, let's say we were to set x equal to 3. Alright, so if we were to plug x equals 3 into our equation, we would plug it in and we would write it in this form. We would say that f of 3, the output when we plug in 3, should be equal to 2 times 3 plus 4. So where the x once was, we're now replacing that with a 3. And then we would just simply solve this problem out. So that means f of 3 is equal to 2 times 3, which is 6, plus 4. And that means f of 3 has to equal 10. So the output when we plug in 3, remember 3 was the input for this function, okay? So 3 was our input. The output that we get as a result of plugging that in is 10. So our output f of 3 is equal to 10. Okay, so for instance, sometimes you'll come across problems that will say f of 3 equals, and that just means plug 3 in. This is your input. Since it's inside the parentheses, that means it is your input. Okay, so that means plug it into the equation where the x goes. So we would do 2 times 3 plus 4, and our answer that we would get as the output would be equal to 10. Alright. Now, on the other hand, sometimes you'll come across problems that, let me clear the screen here real quick. Sometimes you'll come across problems that will ask you to come at this from a little bit of a different angle. Okay? And what they mean by that is, let me go ahead and clear this all out real quick. Come on. Nope, it's not all clear. Alright, let me try this way. So what they mean by that is they want you to figure out, going backwards, what value could have been plugged in to get a particular output. And those problems, or those questions, will look something along these lines. They'll say f of x equals, let's say we were to look for when f of x equals, I'm just going to pick a number here, 16. Okay. Now remember, our original function, the output f of x was equal to 2 times x plus 4. Alright? So we're looking for when does this function equal 16. Well, notice if f of x equals 16 and f of x equals 2x plus 4, that must mean that 16 equals 2x plus 4. Okay? Maybe it would help if I wrote it this way. What if we switch these around and we said 16 was equal to f of x? Alright? Well, obviously f of x is equal to f of x right here. Okay? And so if this is equal to f of x and this is equal to f of x, then by property of mathematics, we know that 16 has to equal 2x plus 4. So we simply go back and solve this equation to figure out what input could have given us an output of 16. So to solve this, it's a linear equation. We subtract 4 from both sides. Alright, 16 minus 4 gives us 12. And we're left with 2x on this side it just comes down, and the 4's cancel each other out. Positive 4, negative 4 cancels out. So we're left with 12 equals 2x. So we can divide both sides by 2, and 12 divided by 2 gives us 6. So that means the input that results in an output of 16 would be x equals 6. So let's just double check this to make sure. Let's say I was to plug in 6 into my equation. That would mean 2 times 6 plus 4. Now we're expecting f of 6 to equal 16. Okay? When we started with 16 and worked backwards, we got an x value of 6. So if we plug 6 into the actual equation up here, we should get that same result of 16. So let's try this out. 2 times 6 is 12 plus 4, and in fact 12 plus 4 does equal 16. So we know we did it correct. Alright? So if they give you f of x equals a number, that means they're giving you the output. Okay? In which case you're working backwards to figure out what value of x could we have plugged in to give us 16 as the answer. And we solved and figured out it was 6 here. The previous problems we saw was where it said f of 3, and that's where they give you the input, and all you simply do is plug it into the equation. Okay, so we plug in 2 times 3 plus 4, and as we saw earlier, 6 plus 4, which equals 10, so this would be our answer. F of 3 would equal 10. Okay, so these are generally the easier of the two problems. There's not really a lot you have to work to solve for x. If they give you f of x equals a number, where they give you the output and they ask you to find the input, that's where you have to work backwards and solve your equation for x, as opposed to just plugging it in like we did over here. Okay, so watch the next video for a couple more example problems, and then go on to the practice problems.